Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 2.3 from the C programming language textbook by Brian Kernighan and Dennis Ritchie. Now, exercise 2.3 says to write the function htoi, which converts a string of hexadecimal digits into its equivalent integer value. The allowable digits are 0 through 9, A through F, and capital A through capital F. Now, just to remind ourselves, these are what the letters correspond to in terms of decimals. In the main function, I have 3 lines written to test the htoi function. And here I have the actual htoi function that we are going to be implementing. Now, the first thing we need to do is keep track of the index into the string. So I'm going to use an integer I to keep track of this. Now, before we actually do anything in terms of conversion, we need to check if the user has put in a leading 0x. If they have, then we should skip over it. We don't want to convert 0x. I mean, it means nothing. It just means that this is a hexadecimal. So if the first element is equal to 0 and the next element is equal to either lowercase x or the next element is equal to an uppercase X, then we want to skip those 2 characters. So we should move our index along by 2. And just to make sure that the logic of this is understood, I'm going to put some more brackets. So here, if the first character is 0 and the next character is a lowercase or uppercase x, move along the index by 2. So skip it. Next, we're going to create an integer called res for result, and this is going to hold the result after converting into an integer. Now, we should first, only convert if we have a valid hexadecimal character. So, to check this, the hexadecimal character can either be a number, so it can be larger than or equal to the character 0, and it has to also be less than or equal to the character 9, so it's between those valid characters, or it could also be a lowercase character, so it has to be larger than or equal to A, and it has to be less than or equal to lowercase f. Or what if it's an uppercase character? It has to be larger than or equal to capital A and less than or equal to capital F. Now, if all of that is true, we can go about our conversion. So I'm going to use an integer hex num, and this is going to store the hexadecimal value of that specific digit. So the first thing we need to check is what type of digit is it? Is it a lowercase character, uppercase character, or is it just an integer? So the first thing I'm going to do is check if it's an integer. If it is, then the hexadecimal digit of that, particular character is equal to that character minus the character 0. And this is because in the ASCII table, if you just look it up, all the character of numbers, the character 0, the character 1, the character 2, they are all one right after the other. They are all ascending or in ascending order. And therefore, if we take the difference, we get the actual integer. For example, if SI was 5, then 5 minus 0 would be 5 in the ASCII table. Otherwise, what if we had a lowercase character? Well, we need to convert it again, but we have to be a little more subtle. S of I minus the character A, because likewise, A through Z, lowercase a through Z, is all one right after the other. They're all contiguous in the ASCII table. So right after A, there's B, right after B, there's C. And so, for example, if we had here C, then C minus A would give us the value of 2. However, that is not what we exactly want, because C should be 12. So we're only off by 10, and so we need to add 10. Otherwise, I mean, we could technically do another check, but if we're inside this loop, then the only other possibility is that we have an uppercase character. So I'm just going to save us doing another check, and I'm going to do basically the same thing here, but with a capital or an uppercase A. Then after that, we can change our result. So our result should equal 16 multiplied our current result, and it's 16 because we're in the hexadecimal scale. And what this does is it essentially moves everything, or moves our current result over to the left by 1 digit. So if we had 51 as our current digit, multiplying it by 16 would make it 510. And then we can change that 0 to be the least significant digit or the current digit, which is hex num. And we should also not forget to move along our counter I. Then after all this, we should return the result. So let's compile this. Hopefully no errors. Okay, that's good. And then let's run it. The hexadecimal value of 0x5F32 is 24370. And just to check that, I've got this website here, and you can see the hexadecimal value of 5F32 is indeed 24370. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.